One really important idea in geometry is proving certain shapes on the coordinate plane. So we might have a coordinate plane, we might have a triangle, we might have a trapezoid, we might have an irregular shape, or we might have a rectangle, and we need to be able to prove that these are in fact geometric shapes on these coordinate planes. So a really useful skill that we need in order to prove geometric shapes on the coordinate axes is we need to be familiar with the topic of slope. So this video centers on that exact idea. We're just going to review what it means to find the slope of a line. So the first 2 pages of your note packet have a lot of definitions, and I'm going to quickly go through those in this video, but I would recommend reading through these more thoroughly on your own. In essence, slope is the rate of change between any 2 points on a line. So if you see in my diagram over here, it's the rise over the run. So if we have points x1, y1 and points x2, y2, remember that slope is change in y over change in x. We normally use the slope of the line represented by the letter m. You might have seen slope represented as the rise over the run. And going along with that x1, y1, x2, y2, change in y over change in x, you find the difference between the y's and you do the difference between the x's. You can label either point as x1, y1, and so on and so forth. In this diagram right here, we have 4 cases of what slope can be. So the first case is negative slope. So from falling from left to right, it kind of goes downhill, like this line right here, and I'm highlighting that in blue. So line J would be considered having a negative slope. We have positive slope. So from left to right it rises, as in line K. I'm highlighting that line here in green. We can have zero slope. So zero slope refers to a horizontal line. So I'm going to use a better color for that. A horizontal line, as in line M. So line M, this is a horizontal line, and this line has a slope of 0. And the last possibility here is having an undefined slope. Undefined slope happens whenever we have vertical lines, as in line N. So straight up and down lines like line N. And those are the 4 typical cases of slopes of lines in a coordinate plane. So moving on to the back page, we have some notes here about slopes of parallel lines and slopes of perpendicular lines. It's really important to know for this particular unit that whenever 2 lines are parallel, they have the same slope. That's really important. So in this diagram here, you see the blue line has slope, and we call that slope m of 1, and the red line has slope m of 2. They are equal to one another. So whenever we have 2 lines on a coordinate plane, they are parallel if their slopes are the same. Any 2 vertical lines are parallel. So if I were to draw a vertical line right next to a vertical line, obviously they would never touch. So if you want to go ahead and take a note here that parallel lines never touch. And perpendicular lines. 2 lines are perpendicular if and only if the product of their slopes is -1. So this is often referred to as being negative reciprocals. When you multiply 2 slopes and you get -1, that means they are opposite reciprocals of one another, and we'll see some examples of that later on in this note packet. One last note here is that horizontal lines are perpendicular to vertical lines, and you see that every time you draw the coordinate plane. When you have the y-axis and you draw the x-axis is horizontal, the y-axis is vertical, and they always meet at a 90-degree angle, meaning that they are perpendicular. Don't forget that the symbol used for perpendicular is kind of that upside down T. You will see this symbol whenever we talk about perpendicular lines. So let's talk about actually doing the computation to find the slopes of different lines. So we have 4 different lines here. We have lines A, B, C, and D, and they want us to find the slope of all of those lines. So let's first find the slope of line A. Line A, so we see that this point here, 6, 4, is shared by all of the lines. So 6, 4 is on line A, and line A also has the point 8, 2. You always need 2 points to find slope. So slope, remember, is rise over run. Okay, so to get from point 8, 2 to point 6, 4, you have to rise up 2. And you have to run to the left 2. Since to the left is in the negative direction, I'm going to make my run be -2. 2 over -2 reduces to -1. So that means the slope of line A is -1. And that makes sense because line A, if you read from left to right, is going downhill, so it has a negative slope. Slope of line B. Line B is going uphill, so it should be positive. Again, we have points 4, 0, and again that point 6, 4. So rise over run. We have to rise up 1, 2, 3, 4, and we have to run to the right 2. So rise over run is 4 over 2, which reduces to 2. So the slope of line B is 2. Next line is line C. Now we can already see line C is vertical. Line C is horizontal. But we can still find the rise over the run. So the rise actually is 0. We're not rising at all to get from point 0, 4 to point 6, 4. We don't rise up or down. And the run is 1, 2, 3, 4, 5, 6. 0 over 6, anytime you have 0 in the denominator is always 0. So the slope of line C is 0. And lastly, line D. We see line D is vertical. We have the point 6, 0, and again the point 6, 4. So the rise over the run. The rise in this case is up 1, 2, 3, 4. And the run in this case, now the run is referring to how much we moved left or right, and we didn't move left or right at all, so that's 0. Now, anytime you have 0 in the denominator, that becomes a problem. That means that the value of the slope actually is undefined. So the way we can write that is undefined. You can abbreviate that as undef with a little period, or you could write DNE, and that stands for does not exist. We can never divide by 0, so vertical lines always have a undefined slope. Moving on to example 2, finding the slopes of lines. I will do the first example in this video, and I will save parts B, C, and D for you to do on your own. So for this example, I really want us to use this definition that slope is y2 minus y1 all over x2 minus x1. And that's when we're given the points x1, y1, and we're given another point called x2, y2. So it's the change in y over the change in x. So if I zoom in here to part A, just zooming in, I want to label my x1, y1, and my x2, y2. So I'm going to call this first point my x1, y1, and I'm going to call my second point my x2, y2. Now it doesn't matter which one you choose, I just like to choose that one because it came first, so I call it x1, y1. So using the setup of my slope, I'm going to take the y2, which is -2, and I'm going to subtract, as in my formula up here, I'm going to subtract it from the y1, which is 4, all divided by the x2, which is 5, minus the x1, which is negative 7. So when I minus a negative 7, it's a good idea to use parentheses since we have two negative signs in a row. So let's reduce this. Negative 2 minus 4 comes out to be negative 6, and 5 minus negative 7, remember that when you subtract a negative, that's the same thing as adding. So I'm really doing 5 plus 7, and 5 plus 7 is 12. Now technically I found the slope, but I can reduce this, so I'm going to. If I divide 6 by 6, I get negative 1, and when I divide 12 by 6, I get 2. So the final reduced slope between these 2 points is going to be negative 1/2, and that is my final answer. Okay, and like I said, for the rest of this example, I'm going to save that for you to try on your own. So for example 3, this is an example of when we're given some lines that lie on the coordinate plane, we have to determine which of those lines are parallel and which of those lines are perpendicular. So even though all of them, if you look at that long purple line right here, line D, it's really tricky to tell which one of these lines, either line A, line B, or line C, which one is exactly perpendicular. So we can't tell just by looking at the lines. We actually have to compute the slopes and see which slope has the opposite reciprocal slope to line D. We also don't know if line A, B, and C, which of those are the parallel ones to one another. They look parallel, but they might intersect somewhere later on in the graph, and we can't know for sure until we actually calculate their slopes. So let's go ahead and find the slopes of these 3 lines, and then we'll be able to better determine. So for line A, the slope of that is rise over run. These are the 2 points, negative 3, 2 and 0, 3. So it looks like we're rising up 1 and running to the right 3. So the slope of line A is 1/3. The slope of line B, I'm going to use this point 0, negative 1 and 2, 0. So the rise over the run of line B, we're rising up 1 to the right 2, so that's 1/2. The slope of line C, I'm going to use these 2 points. The rise is up 1, and the run is to the right 2. And lastly, for line D, I'm going to use this point negative 3, 2 and this point negative 2, 0. So the rise is actually down 2, and to the right 1. Negative 2 over 1 reduces to negative 2. You can just write it as negative 2. So now looking at all the slopes of these lines, we need to look at the relationships between them. Now slope A is 1/3. Nothing else matches 1/3, so nothing is parallel to line A. And also nothing is the opposite reciprocal, so nothing is also perpendicular to that line. Now we do see that line B and line C have the same slope. And if you remember from up above, parallel lines have the same slope. So, therefore, we know that the 2 lines that are parallel to one another is, we know that line B is parallel to line C. And remember the parallel symbol is those 2 lines. Now perpendicular, remember that when you multiply the 2 slopes, you should get negative 1. And what actually happens when you multiply 1/2 with negative 2 over 1? When you multiply that across, you get negative 2 over 2, which reduces to negative 1. So 1/2 and negative 2 are opposite because one is positive and one is negative, and they are reciprocal because 1 over 2, when you flip it, is 2 over 1. Therefore, line B is perpendicular to line D, and Also, line C